Hello. So today we are going to study the next cell. Previous video I have taught you the dry cell of a primary cell, clear? And I told you certain things about the primary cell and secondary cell. That primary cell are the cell which cannot be recharged back after its long use, and the secondary cell as a cell which can be recharged back. Okay, and in that we have done the dry cell also, clear? Today we are going to study about the mercury cell, clear? See, mercury cell is nothing but a what? In short, it is a button cell. In a local language we are telling as a button cell. You can see, sometimes you can see the cell which is used in your laser lights, small laser light which are coming for kids, okay, as like a toy. So some small circular cell are coming, you can see, which are also used in your watches. Then you can see in laser lights, then sometimes in cameras, clear? So that type of a cell are known as a what? Mercury cell. Here diagram is not required. Just you have to understand which is the anode, which is the cathode, and to understand the anodic and cathodic reaction, clear? So this mercury cell, okay, so this cell is used in small circuits where low current and low voltage is required. Low current and low voltage is required, clear? If you see their cell potential is nearly 1.35 volt, or you can say their net cell potential. Their cell potential means how much voltage they will give is nearly 1.35 volts. Remember this, clear this part. Example where it is used. So example used in you can say laser lights. You can see, you know, one golden color laser light is coming. When you press it on the wall, you can see certain designs will come, like star design, heart designs. Okay, so that laser light, clear? So used in laser lights. Then it is used also in the watches, yes or no? Then it is used in cameras, okay, etc. In many devices it is used where the low voltage or low current is required. Now you have to understand which is anode and which is cathode. So how to remember? See, I will write down here anode and I will write down here cathode, and we will see the electrolyte. Here anode used is zinc amalgam, ZnHg, okay. So you know zinc amalgam is anode here, okay. And what do you mean by amalgams? Means the solution prepared in the mercury. Means zinc, here the anode is zinc amalgam, and zinc amalgam means what? What do you mean by amalgams? Amalgams means the solution prepared in mercury. So here anode is used zinc amalgam, and it will convert into zinc oxide. Then at cathode, mercury oxide is used, which will be converted into mercury, Hg. And the electrolyte here field is, this portion is electrolyte. I will tell you one thing. First listen here, electrolyte. And the electrolyte is field is paste of KOH and ZNO. So this is the electrolyte, paste of KOH and ZNO. If you remember in this way, see, this is the method to remember who will be anode, who will be cathode, and what. See, remember in this way. Every cell, if you remember, you can write down directly the reactions. In this type of a cell, they are just asking the reaction. They will not ask the explanation, or they will not ask any kind of diagrams. They will just ask the direct equation, anodic reaction, cathodic reaction. So this is the technique to be remembered in exam. So see, this portion will be anode and this portion is cathode. Which anode we are using? Here zinc amalgam is used as an anode, and this will be converted into zinc oxide. Here cathode is used HgO, mercuric oxide is converted into Hg, and electrolyte field is paste of KOH and ZNO. Electrolyte field is KOH and ZNO, okay. And I told you what do you mean by zinc amalgam. Zinc amalgam is nothing but the solution which is prepared in mercury. So now we'll see the reaction anode. So at anode, so this zinc amalgam, okay, this is zinc amalgam is converted into what? Zinc oxide. Sorry, this zinc amalgam is converted into zinc oxide. Clear? This zinc amalgam is converted into zinc oxide. Now it is anode, and you know at anode reaction means electron will be lost. Now who will help this zinc to convert into zinc oxide? This KOH. So here the paste, this electrolyte. So you know this is a KOH. This KOH will get split, K plus and OH minus. So here OH minus will react with zinc amalgam, that is zinc, and convert into zinc oxide. Clear this part? So here who will help? Zinc amalgam. This is a basic medium reaction actually. It is not an acidic medium reaction. This is a basic medium reaction. Now you remember here there are the transfer of 2 electrons. How many electrons are transferring? 2 electrons. So what is the charge? -2 charge. So you know the basic medium charge is balanced by OH minus. So how many charges are there here? 2 charge. So I will write down here 2 OH minus. Now how many oxygen are here? So here oxygen is 1, but here oxygen is 2. So where the oxygen is less? In this side. So oxygen is balanced by H2O. Clear this part? So this is the net reaction of anode in the mercury cell. Once more I will see what I have done. I have taken the zinc amalgam, and this zinc amalgam is converted into what? Zinc oxide. This you have to remember. If you remember this, easily you can write down the reaction. So you have to remember this: at anode zinc amalgam converted into zinc oxide, at cathode mercuric oxide is converted into mercury, and electrolyte between them is a paste of KOH and ZnO. Now what happens? This zinc amalgam is converting into zinc oxide. You know it is an anode. Anode means loss of electrons. So electron will be lost. Now this zinc amalgam is converting into zinc oxide by taking with help of what? This help of KOH. So this KOH will split K plus and OH minus. So here OH minus will help. Means here zinc will react with OH minus to convert into what? Zinc oxide. Now OH minus means basic medium. So now how many charges are there? So here you have to remember there will be transfer of 2 electron. In this whole circuit there will be transfer of 2 electron. So 2 electron I have written here. Now how many charge are there? So 2 charge. So charge balanced by OH minus. So here 2 charge means charge balanced by OH minus. So 2 OH minus. Now here hydrogen are 2. So here also hydrogen 2, but oxygen are 2. Here oxygen is 1. So oxygen is balanced by H2O. So here H2O. Once more I will write down the reaction. Please focus it. At anode I have zinc amalgam. It is converting into zinc oxide. Anode means loss of electron. Clear? Anode means loss of electron. Which medium? This is a basic medium. So you have to remember here how many electrons are required in this circuit. Please remember this: 2 electrons are required. So this is important point. You have to remember this. How many electrons are required in this circuit? 2 electrons. So 2 electrons is required. Now this is a basic medium, acidic medium. Due to presence of KOH, this reaction becomes a basic medium reaction. Now you know in basic medium, charge balanced by OH minus. So how many charge are there? 2 charge are there. So here charge balanced by OH minus. So 2 OH minus. Clear? Now how many oxygen are here? 2 oxygen, but here oxygen is 1. So where is the less oxygen? In this side, product side. So here to balance the oxygen is balanced by H2O. Complete redox reaction, basic. Now how many hydrogen are there? See, automatic 2 hydrogen came. How many charge is there? -2 charge, -2 charge. How many zinc? Here zinc. No need not to worry about this mercury. Okay, this here there is only zinc only. But to show that zinc solution is prepared in the amalgam, I have written here Hg. Need not to balance here Hg. Need not to balance here Hg. This Hg only shows that the zinc solution is in the amalgam form. Clear this part? Okay, so this will be your anodic reaction. Now write down there at cathode. So at cathode I have HgO. This will be converted into Hg. Clear? And you know cathode means electron will be gained. How many electrons should be gained? 2 electron will be gained. Now charge balanced by OH minus. So here 2 charge. So here 2 OH minus. How many oxygen are there? 1 oxygen here, but here oxygen are 2. So where the oxygen is less, here there is a deficiency of oxygen. So oxygen is balanced by H2O. How many oxygen? There are 2 oxygen, but here oxygen is 1. So 1 is remaining. So 1 oxygen is balanced by 1 H2O. How many hydrogen? 2 hydrogen. Totally balanced. And this you know. Okay. Now see here, how many oxygen are there? 2 oxygen. 2 oxygen. How many hydrogen I have? 2 hydrogen. 2 hydrogen. How many Hg I have? 1 Hg, 1 Hg. What is the net charge here? So net charge here is -2. So what is the net charge here? -2. So reaction is completely balanced. Now we write down the net reaction. So writing down the net reaction, I'll cancel this 2OH minus, 2OH minus, this 2 electron, this 2 electron cut, 1H2O, 1H2O. So I will write down here net reaction. So I'll get the net reaction as, what I'll write down? First, all LHS part on the LHS side. So zinc in the form of amalgam plus, see nothing is remaining here, okay, here it will come what? HGO, okay, so here also nothing is remaining, everything I've written of the LHS side gives, first write down the zinc oxide plus Hg. So this is the net reaction, and what is the net electron transfer? N equal to 2, clear? So this is the net reaction of the mercury cell. Now note one thing, see what you note, the note is in the product side. If you see in the product side, please focus here everyone. If you see in the product side, there is no ions are produced, we have no ions in the product side. When there is no ions in the product side, so no change in concentration, no change in concentration means what? Means forever till the cell get dead, forever till the cell get dead, their cell potential remains constant, the cell potential remains constant. This is one key point, that in the mercury cell, when you see in the product side, so in product side there are no formation of ions. When there are no formation of ions, means there will be no change in the concentration of the cell during the usage. So there will be no change in the concentration of cell, concentration of this all product, all these reactants during the cell. Means if there is no change in the concentration, means when you start the battery till the battery get over completely exhausted, the cell potential remains constant. So no change in concentration means cell potential remains constant. Clear? Please note it down. So cell potential remains constant forever the cell till how much time it will work, the cell potential will not change, it will remain from first to last, that is 1.35 volt, it will not get changed. Clear? Okay, so I hope you have written it, take a screenshot. Now next we will go and see, this is also coming under primary cell. This cell cannot be recharged back. Why it cannot be recharged back? Because see here Hg oxidation number is 0, but here oxidation number is +2. So when I supply the current, Hg cannot be converted back into HGO. When I supply the current, Hg back cannot be converted into HGO on passing the current. HGO can be converted into Hg by getting the current, but back Hg cannot be converted into HGO on passing the current. Due to this reason, that Hg cannot be oxidized. Due to this reason, this cell comes under primary cell, not the secondary cell. Clear this part? So I hope you understood. Need not to worry about the extra point. Just remember anodic reaction, cathodic reaction, and net reaction. Number of electrons get transfer. Okay, anodic part, cathodic part, and then electrolyte. Electrolyte is paste of KOH and ZnO. Who is getting in work? This KOH. And due to this KOH, we get OH minus. So this whole reaction becomes basic medium. Clear? So now next topic. Now see here. Next we are going to see the lead storage cell. The lead storage cell is coming under secondary storage cell. Okay, and secondary storage cell, I told you, what do you mean by secondary storage cell? The secondary storage cell is a cell in which once the battery or once the cell is used, it can be reused back on passing the electric current. In short, we say as a recharged. Okay, so this is a lead storage cell. This diagram I have shown. Now see, in lead storage cell, what you are using, you are taking the anode. Anode we are taking as PB. Anode plate we are taking as a sponge lead plate, which is converted into lead sulfate. Clear? And cathode we are taking PbO2, sorry, PB not PbO, it is PbO2. This PbO2 is converted into PbSO4. So here anode portion we are taking a lead spongy plate, and cathode portion we are taking a lead plate, but it is coated with lead oxide. Okay. Next, here we are taking the electrolyte, and here the electrolyte we are taking is H2SO4. Here the electrolyte we are taking is H2SO4. Clear? But which type of H2SO4? This is very important. This is very important question for your exam, the H2SO4 is nearly 98% weight by weight. Okay, so H2SO4 is 98% weight by weight of density 1.25 to 1.30 gram per ml. This condition of H2SO4 you should be remembered. So here electrolyte I am taking is H2SO4 of 98% weight by weight and of density 1.25 to 1.30 gram per ml. So here anode I am taking is Pb, cathode I am taking as a lead oxide plate, and this is one cell only. Okay, and when I connect this kind of number of cells, I will form a battery. Clear? So I am teaching only one cells. Clear? This lead storage cell, where it is used? It is used in car batteries, scooter batteries, or you can see in truck batteries. Okay, so this one cell it is not used. There will be a number of cells which are connected in the series, and we can use as a battery. You can write down one more point: the cell potential of each cell, the cell potential of this will be 2 volts nearly. The cell potential will be nearly 2 volts. Okay, clear this part? Now, so we will see first the anodic reaction, we will see the cathodic reaction, and lead storage cell comes under secondary storage cell. Means what happens now? You can recharge back. So we have to study both kind of reaction. First we have to study the reaction during discharge, and that again we have to study the reaction during recharge. Means any secondary storage cell, see, during discharge, first you understand, during discharge what you are doing? During discharge the chemical is converted into electrical energy. Means during discharge they are acting as electrochemical cell, because what is the definition of electrochemical cell? Chemical into electrical. Clear? During recharge what we are doing? During recharge you are supplying the current, so chemical energy is generated. Means during recharge it is acting as electrolytic cell. So this lead storage cell or secondary storage cell can act as a both. It can act as an electrolytic cell also, it can act as an electrochemical cell also. Electrochemical cell when? During discharge, because during discharge chemical is converted into electrical, and electrolytic cell when? During recharge, because electrical is converted into chemical. Clear this part? So I will start the reaction. So now during discharge, first we will understand the during discharge. Okay, first we will see at anode. First we will see at anode. So Pb is converted into PbSO4. Clear? Now Pb is converting into what? PbSO4. At anode means what? Loss of electron. Now Pb is converting into PbSO4. Who is helping? This H2SO4. So Pb is converted into PbSO4. Yes or no? So who gave the SO4 2 minus? This H2SO4. Means H2SO4 will get split into H plus and SO4 2 minus. So here SO4 2 minus will come and it will convert into PbSO4. Now how many charge are here? How many charge are there? So 2 charge. So here also I will get 2 charge. Clear? Now we'll see everything is balanced. Now see, Pb is balanced. S1 1, oxygen 4 4, net charge minus 2 here, net charge minus 2 here. So means this reaction is completely balanced reaction. Now we will see at cathode. Cathode I have PbO2. This PbO2 is converting into what? This PbO2 is converting into PbSO4. Clear? Who will help? Here also SO4 2 minus only will help. Clear? And at cathode, you know, there will be a gaining of electron. There will be a gaining of electron. Now see the oxygen. How many oxygen I have? I have 4 plus 2, 6 oxygen on the reactant side. But how many oxygen I have here? I have 4. So how many oxygen is deficiency? 2 oxygen is deficient on product side. So here 6 oxygen, but here 4 oxygen. So here there is a deficiency of oxygen of 2. So you know oxygen is balanced by H2O. So 2 H2O, because 2 oxygen is deficient. Now count the oxygen. 2 plus 4, 6. 4 plus 2, 6. Now see the hydrogen. How many hydrogen I have? Here 4 hydrogen, but here I don't have any hydrogen. Now this is contain electrolyte as H2SO4. Means this whole cell is working at acidic medium. And you know, in acidic medium, according to redox reaction, hydrogen is balanced by H plus. So how many hydrogen here? 4 hydrogen. How many here hydrogen? No hydrogen. Means here 4H plus. So your hydrogen is balanced by H plus. So here I written 4H plus. Now we'll see the net charge. So here net charge is 0. Yes or no? But here what is the net charge? When here the net charge is 0, so here also net charge should be 0. So if I take 2 electron, so net charge becomes 0. See here, plus 4, minus 2, plus 4. So here plus 4, minus 2 minus 2 minus 4, so answer will be 0. So your net charge also is balanced. Similarly, say net charge here minus 2, so here also net charge is minus 2. So everything is balanced here. So this is the net anodic and cathodic reaction during discharge. During discharge. Clear? So what are the net transfer of electrons? The net transfer of electron is 2. So whenever if I put any load, and you know the transfer of electron get from where to where? Anode to cathode. So from here electron will come out and here electron will be going. So in between if I put any load, here I put galvanometer, but instead galvanometer you can put any load, say bulb or second horn, or you can say small LED. So this will glow because when there is a transfer of electron from anode to cathode, so here there will be free flow of electron, and free flow of electron itself is electricity. Clear? So we write on the net reaction. So see here, these 2 electron get cut. Okay? Clear this part? Now, once more, anything else we will see. Nothing. See here now. PB. First write down here PB. Then I write down here PbO2. Yes or no? How many SO4 2 minus? See here. I have here 2 SO4 2 minus are 2. But how many H plus? 4 H plus. So I have 2 SO4 2 minus and I have 4 H plus. Now what will happen? You know. Then when one H2SO4 will get cracked, so it will form H plus and SO4 2 minus. It is correct splitting? No. Minus 2 charge means here plus 2 charges. So what I want to tell you is that whenever one H2SO4 gets split, so on splitting of one H2SO4 I get 2 H plus and 1 SO4 2 minus. Now how many SO4 2 minus I have? 2 I have and 4 H plus. Means I will multiply both sides by 2 here. Here also 2, so here also 2. So 2 2 4H plus and 2SO4 2 minus. So 4H plus and 2SO4 2 minus will combine to form how many H2SO4? 2H2SO4. So here 2H2SO4. Clear? So PB, PbO2, SO4 minus SO4 2 minus SO4 2 minus 2SO4 2 minus and 4H plus. When one H2SO4 gets split, I get 2H plus and 1 SO4 2 minus. But I have here 4H plus. I will multiply 2 here, so 2 here also. So 2 2s are 4H plus, 2SO4 2 minus. Means I get 2H2SO4. Means 4H plus and 2SO4 2 minus combined, it will get 2H2SO4. And what else I will get? I will get PbSO4. But how many PbSO4? 2. 2 PbSO4 and plus water. Now what happens? See here. Now it is a very interesting case. Okay, I hope you have written this. If you not, please take a screenshot. Okay, so I am roughing this. Clear? Now see here. See, you know, here you can see in the product side water is generated. So in product side water is generated. Yes or no? What happens? Means when water is generated, so density decreases. Because due to generation of water here, the density of H2SO4 which is filled as an electrolyte will go on decreasing. So as and when I use the battery, water is generated. As the water is generated, slowly density goes on decreasing. When density comes to 1.15 gram per ml, when density comes to 1.15 gram per ml or 1.10 gram per ml, 1.15 or 1.10 to 1.15 suppose. When the density comes to 1.10 to 1.15 gram per ml, what happens? Cell stops. So this cell stops to give the electric current when the density changes to 1.10 to 1.15. Why density changes? Because in the product side during the discharge, water is generated. As the water is generated, the density will go on down. Of what? Of sulfuric acid. So when the density is slowly going down, when the density directly reaches to nearly 1.10 to 1.15 gram per ml, the cell stops working. Cell stops. Okay now. So now what I have to do? I have to do recharge. I have to do what? I have to do the recharge. Clear? So now I will supply the electric current to this everything. Okay. And here I will get electricity also. Plus electricity. Yes or no? PB, PbO2, H2O4, they will convert into PbSO4 plus 2H2 and plus they will give what? Electricity. But due to this water, this water generated, due to this water, density will go down. Now there is a one point that when density comes to 1.10 to 1.15, this is the experimental value, okay. So 1.10 to 1.15 gram per ml, automatic cell working will be stopped. Now what I have to do? I have to recharge, because this is a secondary cell. So we have to see now recharging reaction. So during recharge, see, it's very easy reactions, okay. Now how to remember the recharging reaction? Here see, when I get the electrons, the portion which is acting as anode during recharge, that will act as cathode, and the portion which is acting as a cathode during discharge, during recharge, they will act as an anode. So here the portion which is acting as anode during discharge, that same portion will act as a cathode during recharge. So at cathode, same reaction to return. Yes or no? Now I will be having what? I will be having PbSO4, no? Because after the cell has been over, so in the cell, what it is remaining? This portion only remaining. So I have to write down, how to write down the recharge reaction means, the portion which is acting as an anode, that same portion will act as a cathode, but in the reverse direction. So you write down all the reverse direction reaction. So see now, this is an anode, so this will act as a cathode. Now you have to write down the reverse reaction. So PbSO4 plus 2 electron will generate what? Pb plus SO4 2 minus. You have to write down the reverse reaction, because cathode, see, electron will be gained, so it is gaining. See, if you write down the direct this reaction itself, it is wrong. So how to remember? I'm telling you to remember the reaction. During discharge, the portion that is acting as an anode, during recharge, they will act as a cathode. And that cathode, the reaction should be written in the reversed way, because this Pb and SO4 has been exhausted during the discharge. What is remaining in the cell? The cell remaining is PbSO4. So I am supplying current to PbSO4 only, no? So when I am supplying the current, the anode will act as a cathode during this recharge. Okay. So this will be reaction at cathode during recharge. Now at anode. At anode, what is the reaction? At anode, 2 PbSO4 plus 2H2O will be given what? 4H plus PbO2 plus SO4 2 minus plus 2 electron. So this 2 electron get cut, 2 PbSO4 plus 2 H2O, and what? I am supplying electricity also, yes or no? Electricity. Back what I will get? Back I will get Pb plus this PbO2, yes or no? Plus SO4 2 minus plus SO4 2 minus. How many SO4 2 minus? 2 SO4 2 minus and 4H plus. How much I will get? 2 H2SO4 I will get back. So see, during the recharge product back, I got this Pb plus PbO2 plus 2 H2SO4. So again the cell is completely filled back with this 2 H2SO4 with Pb and PbO2 as a electrodes. Okay. So again I can reuse. But I will tell you one thing. The recharging of this cell is not 100% efficient. Recharging of this cell is not 100% efficient. Why it is not 100% efficient? Because the chemicals has been used now. Clear? So what you have to do? To go for the high efficiency recharge, back we are adding, so to get a high efficiency recharge, we are adding extra 98% H2SO4 of 98% weight by weight H2SO4 of 1.30 gram per ml of density. Clear? See, what I mean to tell is this recharging is not 100% efficient. Okay. Yes, it can be recharged. The battery also will work 2, 3, 4 times, but it is not 100% efficient. So to increase that efficiency, what we are doing, we are adding from outside extra H2SO4 we are adding. Okay, we are filling. After doing recharge, what we will do? The remaining H2SO4 extra we will add. Okay, how much extra H2SO4? Which type of we will add? Same type of H2SO4 extra we will add. That is 98% weight by weight and 1.25 to 1.30, so that the efficiency of recharging will increase. So remember this. This recharging once is not high efficiency. It is not 100% efficiency. To increase that efficiency, we are adding extra H2SO4 as 98% weight by weight and 1.25 to 1.30 gram per ml. Okay. Now this I'm talking about this only one cell. Number of cells are connected and they will compact in a one box, which is we are calling as a battery, and the cell potential of this cell potential is nearly 2 volt. Cell potential of each cell is nearly 2 volts. So number of such cells are connected and they are forming a battery of nearly 12 volts or 24 volts or 36 volts, and that such type of a battery, you know, Excite battery, Amaron battery, they such type of a battery are used in trucks or in the extra appliances or in your home inverter. Many appliances are have. Okay, so each cell potential is 2 volts, number of cells are connected in a series and they will generate nearly 12 volts to 24 volts or 6 volts or 8 volts, how much it is required, but each cell is giving 2 volts. Clear? So these are the discharge reaction, recharge reaction. During discharge, who is acting as anode? That will act as a cathode, and reaction should be written in the reverse way. And during the discharge, who is acting as a cathode, they will be acting as an anode, and the reaction should be written in the reverse way. And here I am getting the electricity in the product side, and here I am supplying the electricity in the reactant side during the recharge. Clear this part? Okay. So I hope you understood. Diagram you can see in your NCERT textbook. If you have not understood, if you are not understanding any topic, please comment me, please ask me. I may speak very fast. You can improve me by saying your comments. Okay. I hope you understood. Thank you.